Static equilibrium 5. Determine the three unknown quantities shown. What we need here is we need the tension in this cable, and then we need the two forces that this pin is exerting on the beam here. If you've ever walked downtown in a big city, you might have noticed that some stores have roofs over the sidewalk and maybe a sign that says what the name of the establishment is, but then there are cables that hold the edge of the roof to the building. That's kind of maybe what we have here. We've got a beam and we've got an extra weight hanging on the end, and then we have a cable that is holding the end of this beam so that it doesn't rotate downward. And we want to know what's the tension in the cable, and if there's a pin here, we can imagine there's a pin here, what forces are acting right there. So let's draw a free body diagram of this case. I'm going to draw the beam a little bit thicker. If this is a sine, the weight of that thing is going to be 150 newtons. Then we're going to have a tension that is going to act in that direction, so that cable has a certain amount of tension right there, and this angle right here, won't it, will be 30 degrees. This beam has a mass of 10 kilograms, so that means it has a weight which needs to act right at the center there, and that will be M times G would be 100 newtons. And then this pin is going to exert some force in the Y direction. We'll call that F pin in the Y direction, and then it's going to exert some force in the X direction, the force from the pin in the X direction. What should we do here? We can sum the forces, we can sum the torques. Why don't we sum the torques about this point right here? So let's try that. We're going to sum the torques about the pin right there. And it looks like the 150 and the 100 and the 150 are both acting in the same sense. So we're going to go 100 times, what's its lever arm? Let's look at the original picture. We're told that the length of this beam is 4 meters. So the 100 Newton force has a lever arm of 2. The 150 Newton force has a lever arm of 4. Those are both attempting to rotate this system clockwise, but then the tension, specifically a certain component of the tension, namely the tension times the what? It would be the upward component here of tension, which acts on the end, so that's going to be sine of 30. Tension sine of 30, that's the force that is perpendicular to the lever arm, which is 4. Clockwise torques equal counterclockwise torques. The only thing we don't know in there is tension. And so therefore we can solve that for the tension force in that cable. I'll go ahead and let you do that if you wish. I got 400 newtons when I solved that. The tension we found to be 400 newtons. Now we need to find FPY and FPX. Well, if we sum the forces in the X direction, don't we find that FPX needs to be numerically equal to the tension times the cosine of 30? See, the tension can be resolved into an X and a Y component as well. And so the only forces in the X direction are the X force from the pin and then the X component of the tension, which I believe would be 400 times the cosine of 30. The tension is 400. 400 times the cosine of 30. If you type that in, make sure your calculator's in degree mode, I got 346 newtons. One more then. Let's sum the forces in the Y direction. Sum the forces in the Y direction. What do we have acting upward? All right, look at my picture here at the top. We've got FPY acting upward, and then we have T sine 30 acting upward. So let me put those on the same side of the equation. Fpy is acting upward. That's the force that the pin, which is right there, exerts in the y direction, plus the tension times the sine of 30. Those are both acting together. And what's acting downward? What's acting downward is this 100 and that 150. That's 250. Now, do we know the sine of 30? I think we know the sine of 30, don't we, in our head? Isn't that 1/2? So that means I've got 200 here and I've got 250 there. Subtract 200 from both sides. I believe Fpy turns out to be 50 newtons. And last thing here, the fact that all of these numbers that we've boxed in came out positive means that they do, in fact, act in the direction that we guessed they acted in our free body diagram.